I did all the previous part in my previous videos. I did A, B, C, D part, CD part in the previous videos. In this video, I'm just going to do the E part. The E part is asking you to calculate the voltage gain VO over VI and VO over vsig. Now let's see how to calculate that. And if you remember, in the part C, we derived an equation that is V output is equal to negative VGS1 times 1 plus RO GM1 times RO2 divided by RO2 plus RO1. This equation I derived in the part C of the question. I did it from the scratch. So if you want to know how to derive it, you can go ahead and watch that one. Here I'm just gonna use that equation we derived, and here instead of this negative VGS1 we put VI. That's the input voltage. Okay, and others remain the same. 1 plus RO, and this one is RO1 GM1, RO1 GM1 times RO2 divided by RO2 plus RO1. According to the question, we are interested in VO over VI, so bring this VI to this side. This is going to be VO over VI times which is equal to 1 plus RO1 GM1 times RO2 over RO2 plus RO1. Okay, now we have to just plug in the values, and the RO values and the GM values we calculated in the part B of the question. We found out the RO to be 200K for all of them, and GM to be 0.89 for all of them. So either you choose GM1 or whatever GM is 0.89, and whatever RO, that is 200K. So we have to just plug in the values in this equation. That is 1 plus 200K times 0.89 milli here, and that one, this is 200K multiplied by 0.89. okay, I need some space, so I'm gonna move this one a little bit more here. Let's put it over here, so I will have enough space to express this. So 1 plus, instead of RO1 we put 200K, and then instead of GM1 we put 0.89 milli. These are the things we calculated in the part B. And then RO2 is nothing but 200K as well. That's also 200K. And then in the denominator we have RO2 plus RO1. Both of them are 200K. Plug them in and calculate this value. If you calculate, you end up getting 89.5 voltage per voltage. Okay, this is VO over VI. Now they're also asking for the VO over vsig. Now let's look at the relationship. Now this one, you can look at the hybrid pi model. That one also I did in the part B. That's I did in the part B, part C, I guess. Yeah, part C, I did the hybrid pi model of this, equivalent model of this. In that one, you can clearly see the RS and the R input resistance. But the relation is the only thing you have to know, that the input voltage is equal to vsig times the voltage divider, that is Rin over Rin plus Rs. If you look at in this MOSFET diagram, it's just right over here, and it's also in the diagram right here. You can see Rin right here. This 50 ohm resistance is the Rs, and the voltage, if you apply the voltage divider, that's the vsig right there. So this is the equation we use that for it. Now what we could do is we bring this exact same equation over here, the one we derive VO over VI, which is equal 1 plus RO1 GM1, 1 plus RO1 GM1, and that one multiplied by RO2, and that one divided by RO2 plus RO1. Okay, and instead of VI we put this value right here. So this is going to be VO over vsig times all this the voltage divider, that is Rin over Rin plus Rs. In the other side it remains the same, 1 plus Ro1 Gm1 times Ro2 divided by Ro2 plus Ro1. Now what we have to do is we have to bring this voltage divider term to the other side and multiply. So VO over vsig become 1 plus Ro1 Gm1 times Ro2 divided by Ro2 plus Ro1, and that one multiplied by Rin over Rin plus Rs. Okay, now what I'm going to do is I'm going to copy this one and bring it to a new page. Okay, now we have to just substitute the values and find the final answer. So here let's substitute all the values. VO over vsig, which is equal to 1 plus Ro1. 1 plus Ro1 is 200k, and the Gm1 is 0.89 milli. Okay, and these two multiply here, and then the whole thing, 1 plus this whole thing will be multiplied by Ro2, that's 200k. That one divided by Ro2 plus Ro1, that is 200k plus 200k. And in the other side we have input resistance. That one we calculated in the part C of this question. In the part C we calculated the input resistance to be 2.247k. 247k ohm resistance. Plug that one in, 2.247k ohm resistance, and then this RS value is 50 ohm resistance right here, plus 50, and that is it. Now we have all the values available. We plugged it in. You just have to calculate the final answer, and if you calculate it, you're going to end up getting 87.531 voltage per voltage, and that's our final answer. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.